Chang. Yeah, I'm from Taiwan, the Minxin University of Science and Technology. Yeah, my coworker, the primary author is Professor C.C. Liu. Okay, I am I'm the other author. Actually, I'm an IT guy. Okay, I work on computer science. Yeah, so the geoscience, the earth science, the climate monitoring work is majorly done by Professor C.C. Liu. I'm here, I got the instruction here to deliver the poster and do the poster presentation. But yesterday morning, I suddenly know that I'm in a session. But in Taiwan has a time difference with Alicante here in Spain. So we're not in time to prepare the PowerPoint presentation, due to the very short time. So I will use the poster to do the easy and simple presentation and save time. And later, if we have questions, we can go to the poster session and we can talk. Okay. My subject is the objective analysis of Typhoon Longwang. Its intensity, which means the wind speed, using satellite multi-channel observations. I said I'm an IT guy. Okay, IT is a rapid changing research field. Right now, I think people will think the knowledge of a computer science professor is shorter than that of a smartphone salesman, because it changes so fast. Okay, and so many things. And the key to the changing is many aspects of knowledge, many aspects of research, including the hardware, the software, and different disciplines. The job here is, in the past, we're using the microwave satellite, which is a polar orbit satellite. It will detect those typhoon. The typhoon means a tropical cyclone, which is a storm from the sea, from the northern, from the sea, from Atlantic, from Pacific Ocean, and which hits the Pacific Rim, the country like Japan, Korea, China, coastal province, Taiwan, or Vietnam, or Indonesia, and Singapore, severely. So typhoon is a concern of those countries, especially when the typhoon was formed. We want to know the wind speed and the severity of this tropical storm. So there are some ways to monitor. We're doing weather monitoring, not weather control, but weather monitoring. We want to know just in time, the speed and the strength of those typhoons. So in the past 30 years, we have some model like Dvorak models, things like that, to monitor typhoon strength, and it's been used for quite a long time. But right now, we have more computing power. Okay, doing computation is a thing that costs a few kilowatts. It's not going to harm the Earth. So we're going to do more computation to have more knowledge to do the disaster prevention. So in addition to those microwave, we use another infrared channel, which is a stationary satellite, to monitor the Pacific Ocean, those tropical cyclones, real time. So we can have a computation to know the changing status of those typhoons. So in addition to the microwave channel, we use an infrared channel. And we have a model called the normalized difference convection index, which is proposed by Professor C.C. Liu and our team. And it's a normalized formula to exclude the extreme conditions and have an index for the strength of typhoon. And because of the big data, the IT collects so much data and stored in some place. So we have some typhoon data from the 2005 Longwang, which is a big typhoon. And we do some analysis on the typhoon, and we have some result. which shows a good promise to monitor typhoon in the future. And our future work about the wind speed and maybe the rain intensity and the typhoon on the ocean surface or typhoon to hit land, the change in status and the evolution about typhoon. So there are still many things to do in the future. And right now we have try to convey this idea about the normalized difference convection index and have the model to apply it on the Longwang typhoon, which is in 2005, and show the promising results. And that's about our job. Thank you for your attention.
Question? Thanks for this very quick overview. But I think if you use the inverse of your NDCI factor, it will be more sensitive. Because the change in WB is small, and you put it in plus beneath that will lose the sensitivity of variation.
Oh, okay. That might be a good idea, yeah. So it's still under experiment, so.
Yeah, it's the same data, everything is the same, but just use the inverse of it.
Okay, thank you. And more questions? Wow, yes.
You can predict speed of this nasty tide. Can you predict rainfall?
Yeah, that's our objective in the future. The typhoon right now, the major harm is the rain intensity. So like 2009, there's a disastrous typhoon, which is Morocco. It caused a whole village, buried in the mudslide. So,
what lead time will it be? Can you predict it half an hour, 1 hour in advance? Or?
the ideal thing is to half an hour, but I'm not and the accuracy is also another issue. So when people will in Taiwan, people will complain about the government. Hey, why a typhoon vacation? It's calm. Everybody went to the theater, but the government, at the government standpoint, they have to be careful. It looks like a big one, so they have to give a vacation to the whole country. But later, when it turns out to be calm, and citizens will complain. That's okay. Another, yeah, here.
No, just a comment about what he said. Typhoon is the main problem with it is the velocity of the wind. You see, but if you want to take the rain into consideration and prediction of rain, that you will gonna get more factors in studying that predict. And I believe it's not so easy to do.
Yeah, that's right. And the Taiwan is a mountainous. There are high mountains. So when typhoon come in to Taiwan from different angle and different direction, it cause a lot. It's a lot different. So because the rain tends to fall on the coming side. I mean, not the back side of the mountain. So it's to the geology rather than the weather. It's really complex, and it's a localized problem according to your mountain and your things like that. And okay.
All these things are from 2005.
Mm-hmm.
And I'm wondering, I think that there is some differences between the typhoon in the different area and the different year.
Oh. Mm-hmm.
So I don't know if you have the recent data.
I think we're working on it. Yes, all the typhoon data is opened to academic. When time is right. So.
I'm wondering if there is a significant differences between all these years, all along these years.
We cannot say, but because the global warming, maybe there's a great difference. But we cannot say unless we have enough time to do the observation. I mean, thank you. Yeah, thank you. And yeah.
Yes, I think that's a really interesting study in Taiwan area, and I'm also come from Taiwan, and I do believe you do a good job for this research
Yeah.
Recently, is it working very well, or still have some modification to make a comparison with some?
Thank you. Yeah, we're on our way to further investigation into these questions. In fact, right now, Professor C.C. Liu is holding Liu Chongzhi. Yeah, he's heading a project to do the rain intensity.
It's supposed by the Ministry of Science.
Yes, yes. So yeah. So he's still working on it, but we will try to share and communicate our result. Yeah, in the future. Thank you very much for your suggestion. Thank you. Okay, thank you.